Hello guys, my name is Paul, and my group members are Simran Jet and Mamadi. Our group topic is the process of Railpen Cipher. We first start by giving a definition of the Railpen Cipher. It is one of the simplest ciphers used to crack codes and reveal messages by shifting the number of plaintext to a mix-up of ciphertext. We focus our attention to the process of encryption. The plaintext letters are rearranged by having them be written in a zigzag direction as a way for computer programmers to read off the message from row to row. We have 3 steps. The third step is optional though. Step 1. The message is written diagonally downward to the right and then stop once the number of keys is reached. The number of keys support the idea on how many rows there are in the grid for writing a message. Step 2. The message is written diagonally upward to the right for the next row of plain text letters and then stop once the number of keys is reached. To explain more on step 2, the process goes on until the end of the secret message is reached or end off by the length of the plaintext. Finally, step 3 being optional, if and only if there are leftover boxes of our message, the empty boxes get labeled as X's, or in this case nulls, because there are blank spaces that will not be used for the message being encrypted. This helps programmers accomplish the process of decryption because this helps them know the value of the length of the plaintext, which will give them the idea on how to create a layout of the length of the ciphertext. What we have here are two examples for how encryption works. The first example may be referred to as the simplest Railfin cipher. You see 2 rows, and by counting the number of boxes, there are 17 boxes, or 17 columns. In, in terms of the key and the length of the ciphertext, the key is 2 and the length of the ciphertext is 17. At first, our message in plaintext would be defend the east wall. However, by doing encryption, letter D gets placed in the first box, and then by going diagonally downward to the right is E in the last row, and then by going upward diagonally to the right, from E we go to F. And as this process goes on, we read off the first row to the last row, which is DFNTEATALEEDHESWL. That's the ciphertext message. In our second example, we have the same plaintext message, only this time we're going to add in a new row. While the length of the ciphertext or columns remains unchanged, the rows and key get to be changed. At first it would be 2 rows or the key being 2, but because we add another row, it will be 3 rows and the key will be 3. By going diagonally downward to the right, we start from D, going to E, and then going to F, from first, second, and third, diagonally. And then by going upward diagonally to the right, we go from F to E, then to N, upward, from the last row to the second row to the first row. Once we reach the end, the ciphertext message stays the same. Only in this case, we get to see one thing in particular, 2 X's. As explained from step 3 or the last step, the X's get placed once there is no more need of using this space, because we fill in the message and that with the remaining spots, we don't need them. So since the ciphertext doesn't change, there were, however, spaces of boxes. And that is an example of encryption. Now we focus on the process of decryption. In this process, the grid must be constructed by rows and columns, or in other terms, by the key and the length of the ciphertext. Step 1. First letter of the ciphertext gets placed in the very first empty box in the upward left side of the grid. By going diagonally downward to the right, dashes gets to be put in empty boxes until they have reached the number of keys, rows that the grid holds. Step 2. By going diagonally back upward to the right, dashes get to be placed in again in empty boxes except for the very top box, which is in the first row, because that is where the second ciphertext letter gets placed in. To explain further, this process goes on until the maximum number of ciphertext letters for the first row is reached. Our last step is that the second step continues for the rest of the letters in order to fill in the rest of the message. This goes row by row in different stages until the length of the ciphertext is reached diagonally. What we have here is an example of decryption. We have the ciphertext message being TEKOOHRACIRMNREATANFTETYTGHH. Let's say we were asked 4 rows and 28 columns. The key will be 4 and the length of the ciphertext will be 28. So we have 4 rows for the key being 4 and 28 columns being the length of the ciphertext 28. In the first stage, the first 5 ciphertexts T, E, K, O, and O gets placed in the first row, in which the letter T gets to be placed in the very first box, then going diagonally downward to the right and upward diagonally to the right gets to be placed dashes, and then from the first row, the E gets placed, and then continuing forward, the rest of them get placed. In the second stage, we deal with the second row. Same as the first row, the next 9 ciphertexts H, R, A, C, I, R, M, N, and R gets placed in where the dashes are. And from there, we have the third row and the last row being with dashes. In the third stage, we deal with the third row, and the next 9 ciphertexts E, A, T, A, N, F, T, E, T gets placed into the dashes, the third row. We start with E from where next to where the letter H is diagonally, and then from there putting A next to where R is diagonally. And it goes on forward until these next 9 ciphertexts gets to be placed in for the third row. And the final stage is where the final 5 ciphertexts Y, T, G, H, and H gets placed in its remaining dashes there is. And then once every letter is placed, there is no more dashes. By reading up the plain text in the diagonal direction, the secret message is, they are attacking from the north. And that is an example of the problem.
Good morning, Professor. Good morning, everyone. My name is Mamadi Kaba, and today we'll be talking about the reference cipher, some problem and advantage that we face while using this cipher. The reference cipher problematic has always been the major reference point when cryptographic algorithms are discussed. The advantage of the Caesar cipher is its simplicity. It has a special case of the Cipher cipher. The fact that it is easy to implement it is the main advantage. Even though the opponent trying to decipher the message doesn't know that it was encrypted using Caesar cipher, but notice that it uses some kind of shift cipher. The key space of all possible keys has the size of only the size of the alphabet. It is a very small size. A brute force attack trying all the 26 keys will break this crypto system easily. Another good point of the Caesar cipher is that it is a very simple to use. All a person has to do is to write out his message and then referring to his cipher, rewrite his message again. now encrypted. To give the recipient the key, one can just tell them, for example, move back 3. So C will represent by Z and D will be represented by A. No machine or device had needed to decode it. As we can see, the real fence cipher has been decrypted by using it and arranging it in column or row before reading it. Therefore, it is a quite a easy and fast process, and it is less prone to mistake. Problem that the railfan cipher faces is that the security of the code is dependent on the fact that cryptanalysis does not know the method of encryption. Hence, once the method of encryption is broken, the code is already broken. Another problem with the railfan cipher is that it is not very strong. That means that the number of possible solutions are so small that a cryptanalysis can try them all by hand. Therefore, the real fence cipher is very easy to break as we only have to test all the possible divisor up to half the length of the test. Some disadvantage of this cipher are. To finish this presentation, I would like to add up some disadvantage. It is not very secure, especially for such message. It has a limited number of keys. For enough transposition of letter, length of plain text to be at least 3 times of key. Selecting inappropriate routes end up with bar of plain text, actual message in right direction in ciphertext. The security of the code is dependent on the fact that cryptanalyst does not know the method of encryption. Thank you everyone, and I would like to thank especially my teammate.
Hello, this is Simranjeet, and I will be presenting you next few slides. Is rail-fence cipher still used today? Due to modern advances of technologies, the rail-fence cipher is very weak against keeping the text secret in today encryption. Two well-known attacks that can be used against RFC are brute force attack and frequency analysis. Frequency analysts use frequency of letter or group of letter in ciphertext to decipher group of letter to reveal its true letter or the word. Such cryptanalysts may use against an RFC to reveal its true text because RFC ciphertext is produced by transposition cipher. Another form of attack is brute force, which is a type of attack that tries every combination to decrypt the ciphertext. In RFC case, an attacker may use all the practicable number of rails levels because of small number of keys that RFC uses. To address this problem that this RF rail fence cipher have, we came up with a new implementation of this cipher, and we're calling it RFC and RSA cipher, which combines RSA, which stand for Ribus, Shamir admin, encryption to RFC. RSA is a asymmetric algorithm which uses public key for encryption and private key for decryption. Instead of setting your own rail, the program gives you the number of rails depending on the input text. Output, private and public key. Key size is 2400 byte. The ciphertext is encoded in base 64 and shuffled with RFC technique. Need rail to decrypt the ciphertext. We need to input the number of rails that the program give us when we encrypting the data, the ciphertext, and the private key to decrypt the message. Now, if you go to next slide, which is code and demo, let's look at the code. I posted on GitHub, which you can look at it. So that's just a brief summary. It has files, three Java files, classes, as in Java. It uses Railfence Cipher, which is using a two method, which is like get RFC decrypt data and RFC encrypt data. What it does is that it encrypts in an old-fashioned way, which is you have to given the data you want to encrypt and the number of rails that you want to encrypt it with. And it goes same with the RFC. It uses the same technique. As you can see, look at the code. It's very familiar because it's the same process with the decryption as for encryption. And if you go back, you will see another Java class which got RSA and RFC util. This what I would say is the main, like not the main, but actual backbone of this whole program. In this class, you have many methods that combines the Railfence Cipher class into one. So, just a brief introduction of the method is that you having this method calling a public key, which actually get the public key, or which you have to give in the string, which is 64 public key. And you get the private key, which is same process, but it's encrypting in the private key, as you can look at it. And then we have encrypted RSA, decrypt RSA, which is for decryption for RSA and encrypting for RSA only. It's not combining RSA and RSC yet. Then there's two method, which is taking two different parameters, so you can look at it. Okay, now we come to the RFC and RSA together. The method name encrypt RFC and RSA. What it does is takes encrypted data and number of rails and public key, and it goes same for the encrypt too. To encrypt the text, you need to have decrypt data, number of rails, and private key. And here is just generating a public and private key individually, as you can look at it. So in short, RSA and RFC util.java has have a backbone of this program which has all the methods which combining RSA and RFC together. Now this is the main class is that which is called RSA and RFC encryption main. That's what I called it, and what it is that it gives you the UI of the program. Perhaps what I mean by the UI is that it actually gives you the program input, how the user interact with the program and actually utilize RSA and RFC util class. Now, as for demo, let's look at the demo. I have the note here so that I can keep track um, of the encryption I will be demonstrating. Okay, so if I run this, the program will give you an output of choosing between all these choices. So if you choose one, which is encrypt data, choose two to decrypt data, or three to simply exit the program. I will choose one to encrypt data. It asks, enter the text to encrypt. Make sure it's not bigger than 254 bytes. So I'm gonna enter text. I'm gonna call it presentation. Actually, I'm gonna get my name with it. Synergy presentation. Enter. So when C press enter, it actually output the number of rails, your private key, your public key, and your ciphertext. And I also give you the decrypted message, which is synergy presentation, but that's not what we're looking for. That's what we're looking for when we do choice 2 decrypt data. Okay, now if we actually utilize this, we're gonna choose second option. For the second option, we need a number of rails, which are 14. Private key. I'm going to copy this. Make sure it's not copying the white space. I'm going to paste it here, and I need a ciphertext. I'm not copying public key because for decryption you don't need a public key because key is for available to everybody to see and private key is only for you to see. Right? Okay, so I'm going to choose option 2 now. Decrypt data is asking you to paste in the private key, which is this. I'm going to paste it here. Press enter. Enter your ciphertext, which is this. I'm going to paste here. Now enter number of rails, which is 14. Oh, enter. Now this is the output I get, the secret message that I originally written. RC and decrypted SIMG presentation. And I actually keeping the actual capitalization and the symbol same. So it does not mess with the format of the encryption through text. And that sums up this presentation. Thank you.